There we go. Okay, so this is all new for me, and we're just going to try it out. All right, characteristics of a function. Let's go. What do you remember about a function? Give me anything. What do you remember? A function. What do you think of?
Straight lines.
Line. Okay. Can be a line. Doesn't have to be a line. What else? Domain and range. Excellent. Let's write that definition of a function involves domain and range. A relation in which every element good of the domain corresponds to what? Exactly one element of the range, right? So again, it's we're in that situation. Aiden's playing a soccer game, and is it possible for Aiden to score 0 goals in a game?
Yeah.
Is it possible for him to score 10? Is it possible for him to score 1 and 5? No, that's not possible. It's got to be one or the other. So he's the input. The output is number of goals has to correspond to 1. Corresponds to exactly one element of the range. I'm going to be working on my handwriting as we go. I'm going to, change the font size and those type of pieces. So I want it to be cleaner than that. Totally getting used to this. All right. So calculus really likes to do with functions. You may wonder, where does this idea of calculus even come from? I think it's one of the most beautiful things in the entire planet. I'm going with my wife, okay, pretty beautiful, and then I'm going with calculus shortly thereafter, okay? It is awesome. And the word calculus means the ability to calculate the infinitely large and the infinitely small, or the infinitesimal. And it turns out that calculus is very, very useful for things like functions. And to give you an idea what calculus kind of is, more or less, is, do you agree that the Pythagorean theorem is useful?
Yes.
Yeah, we use it to solve right triangles, right? Pythagorean theorem is useful, and you can use it to solve different things. And actually, from the Pythagorean theorem, we develop all of trigonometry from that, right? But it all stems from the Pythagorean theorem, okay? So calculus has a couple things that are kind of like the Pythagorean theorem, and you use them towards all other cool things, and it really opens up mathematics. Super beautiful. So let's just talk about a couple of these things that we should know. These are things that you should know, and we're reviewing them together. It says the graph of f is given right over here. It says state the value of f of -1. Talk with your peer right now. See if you can come up with f of -1. Just guess. Go. Five, four, three, two, one. F of -1. Anybody? Yeah, -2. So if you go back 1 unit, you would go down 2 in order to find that location. So -2. Estimate the value of f of 2. At 2, what is approximately the height of the function?
3.
Yeah, I'm gonna say like 2.8. For what values of x is the function equal to 2? Don't say it out loud. Talk with your friend next to you. See if you can see for what values of x is f of x equal to 2. Talk. Go.
What's values? I can get up there.
Okay, anybody, what were your thoughts? What'd you go with? Yeah, so if I go back 1, 2, 3, if I go back here, it looks like it has a height of 2 there, so I'm going to say x equals -3. And then, along with -3, I'm going to go over to +1, that those would be the 2 spots. Okay? Estimate the values of x such that f of x is equal to 0. It's the same type of thing. We don't need to do it. Let's talk about the domain and the range of f. Let's talk about domain first, okay? Domain. Domain is the set of all values that produce an output that are inputs. So as I look at this piece, so the whole erasing thing, I went to pick up the smartboard eraser right now. We don't have that option. So let's see, I think he erases that guy, and I think I could just strike lines through and they just go away. There we go. That's kind of cool. All right, I'm gonna take that. All right, for what intervals, or what is the domain of F? Where do I start gathering?
-3.
-3 until? 3? So domain would be from -3 until 3. How about the range? When do I start gathering Y values?
-2.
-2 all the way up to 3. Okay, so those are basic pieces of a function that you should be able to identify. It says, on what intervals is F increasing? Am I increasing or decreasing right now? Decreasing. So it would be from, say, -1 on up, to that spot, it would be increasing. We don't need to write that down. I think it's pretty obvious, okay? Right now, what I would like you to do is try to do A and B on your own with a partner. Go ahead, see what you come up with. Go.
I know. 2.5. Yeah, 2. Okay, and G. Oh wait, did we choose the right line? We chose the wrong line. Are you sure? Yeah, because F is this line, so it's down here. Yeah. And G is this one. Oh, but
Very good. Make sure you figure out which one is F, which one is G, which one is F, which one is G.
wouldn't it be just 2? -2 for F. Because this line.
The graph.
F is -4. Yeah. So it'd be this. Oh wait, I was looking at Y because it's Yeah. This point or because we're on the F line.
All right, pause. Let's talk together here, okay? I want to state the values of F of -4. F is going to be this top function right there. So -4, I go back 1, 2, 3, 4. So I'm going to say it's at a value of, got my marker on right here. Let's see if I can use the red. Does that? Yeah, there we go. So that's F. And I would say that I have F of -4 would be produced 1, 2, 3, 4. So it'd be right about there. Did you come up with -2?
Negative.
And then G of 3, so that's going to be, I'll say, the green function. And if I produce G of 3, 1, 2, 3, looks like I have a height of 1, 2, 3, 4. So I've got 4. Are we good? Did I do that correctly? All right. What do I understand this to be? For what values of x is f of x equal to g of x? What does that mean? Somebody describe it to me. Where do they intersect? Where are the functions equal to each other? And I have that. It exists right here. So when are the two functions equal to each other? Well, that would be at x is equal to -2 and to +2. Right? -2 and +2. Okay. The other stuff I'm pretty confident that you know, just as a nice review, I'd like you to do letter E, check with your friend, state the domain and the range of F. Notice I've drawn F as that red function. Please try to state the domain and the range. Don't know if I can pause my recording. That's kind of what I'm wondering about here. Yeah? Is where you're at?
Yeah.
Oh, good? Great. All right, so those are some basic operations and elements of functions. Inputs, outputs, domain, range. Pretty straightforward, right? Okay, so let's move on to the pieces that are really important. I need you, okay, and this is where I need you to meet me, okay? I need you to meet me. We can't do a pre-calculus review of the entire year. You understand that, right? Some of you guys remember some of the material better than others, and that's just going to be the measure of math student that you are. So there's going to be some times where you're going to need me to slow down. I can take some of that. You can say, can you explain further? Fine. But the fact is, when we're reviewing some of these functions, some of you guys remember exactly what they look like. Some of you are not. You need to remember what these look like eventually. You got that? We don't have time in class to go over why these look like the way they do all the time. You've got to dig deep. You've got to be able to know. So move on to it. So here we go. Flipboard next side. We're going to go over our variety of functions. And obviously, linear function is something that we all know about. Our linear functions say y is equal to x. That's just a line with a slope of 1 and a y-intercept of 0. And we transform that all sorts of ways. Then we have an absolute value function. Y is equal to the absolute value of x. What does that function look like? A v. Can somebody tell me why it looks like a v? Yeah, it makes it positive. Yeah, the absolute value makes it positive, so it jumps up, reflects up on the other side. The exponential function, y is equal to e to the x. Okay, e is a number, 2.71. Okay, exponential function. Think about exponential growth. What would exponential growth look like? Yep, so that's what it does. It actually has a horizontal asymptote of 0, and it takes off like such. Okay. Hovers right along y is equal to 0. That's the general shape. Passes through the coordinate 0, 1. Why does it pass through the coordinate 0, 1? This is what we need, folks. Calculus, and again, the word mathematics means I understand. Doesn't say I know how to do numbers, means I understand. We're going to lean in 2 times here right now to say, so we can understand why. Why does it go through 0, 1? Anything to the 0 power is 1. Excellent. Anything to the 0 power is 1. Everybody got that? Why? Why? Don't go all the way to this page. I don't know how to add a page in. I don't think I actually can. I think I actually go to the whiteboard in this situation. Here's why I've showed you before. Just note, x to the 5th divided by x to the 5th. Would everybody agree if you take something divided by itself, it's 1? Would you agree this is the same thing as x to the 0? Therefore, anything to the 0 power is 1. That's why. Again, we don't make anything up in mathematics. It all comes from this conjecture piece. So we back up here. We have the exponential function. Now that you know the exponential function, you should know the logarithmic function because they are what we call inverses. See if you can talk to your partner and figure out anything about the logarithmic function. Go. Try to come up with anything. You try something. Let's go. Okay, if they're inverses, that means that the domain and the range shift. So instead of going through 0, 1, it goes through 1, 0. Did anybody come up with that fact that it goes through 1, 0? Instead of having a horizontal asymptote, it's going to have a vertical asymptote. So the graph looks like that. It's the inverse. Meaning they are the exact same graphs. It's just one is reflected over the line y is equal to x. So if I reflect this over the line y equals x, notice that I get the same graph. See where they come from? So the logarithmic and exponential graphs are highly connected together. You know one, you know the other. We all good? All right, let's do the easy ones. Power functions. Y is equal to x squared. What shape?
Parabola.
A parabola. Yep, exactly. What is the shape of the cubic? Yeah, kind of that squiggle thing. Notice that if you cube something, it can be negative. If you square a real number, it's going to be positive. But if you cube a number, it could be negative. So that's why it produces this negative piece. Y is equal to x to the fourth. Is it going to look more like x squared or x cubed?
X squared.
X squared. How it's going to be different, I'm going to exaggerate this, is it will slightly flatten out at the bottom. So it kind of has a flatter bottom to it. The resolution on these screens is amazing. I mean, it is sharp. And it picks up everywhere my pen draws. The Smartboard is actually a little bit more forgiving. It's hard to draw something really smooth here. Y equals x to the fifth. That's going to look more like x to the third. It'll just flatten out more as it kind of dives in right there. So really poor representation mathematically, but I did my best. Okay, and then let's do our root functions. Try to get out of here. Do we have a minute left? Root function, y is equal to the square root of x. What does that look like? Yep. Notice how you cannot take the square root of a negative, so notice that the domain is all positive numbers. And then if we had y is equal to the cube root of x, which is the same thing as x to the 1/3, what does that look like?
Is that the speed thing?
It looks like that. Same thing as a square root function, but it has the tail end on the other side. If we stop there, we'll pick up on this tomorrow. There is no need for any homework. I'll get you the homework tomorrow. Or some of you today after school.
After school?
Yeah. Can we?
You
What?
have 8 hour.
I have 8th hour. I might be able to be ready by then.